Okay, Assalamualaikum everyone. Okay, so today we continue with the other subtopic, which is simultaneous confidence interval for treatment effect ataupun simultaneous confidence interval for population lah. Treatment tu sebagai kita punya population. Okay, so hari ni my slide is a little bit different because of the background. So we can see whether this perubahan okay ke tak, whether bila I nak tunjuk sesuatu tu dia akan more clear lah, I hope lah. Alright, okay, so kita proceed. Okay, in our previous lesson before this, you know how to test whether there is a significant difference of all variable among the G population, kan? Using the Manova table, using the Manova method. Okay, the Manova method is used to compare the population mean vector, so we can know whether there is a significant difference or not between all the variables among G population. Okay, so if hash not is rejected, we can conclude that there is a significant difference of all variables among the G population. Kalau you have 3 population, you can say that among the 3 population. So you katakan there is a difference between the 3 population contohnya. Okay, so tapi we cannot know whether the variables that we say that differ tadi differ for first variable and second variable ke, differ from with first variable and third variable ke, ataupun differ for second population dengan third population. We cannot know that using the Manova method. So we have the other method to see whether which population is differ. Sebab tadi kita katakan at least one of the population are differ. So kita nak tahu population mana yang differ for that certain variables. Okay, kita boleh check untuk setiap variables. Okay, so let's see. Okay, we will use the Bonferroni interval for the treatment effect. So you know that the Bonferroni is more precise from the other method of confidence interval. Because of that, we use Bonferroni. Okay, so we will use this Bonferroni interval when the hypothesis of the equal treatment effect is rejected. Bila kita reject hash not, so we need to proceed with the simultaneous test, dinamakan Bonferroni test. Okay, so this is the formula. Dalam your textbook, it is in page 308. Okay, so this is the formula. Dalam your textbook ada dua, sama ada gunakan tau ataupun gunakan X bar. Both of it can be used. Kalau tau, you kena kira dululah. Tau dia punya formula X bar KI minus X bar I. Ataupun you boleh terus gunakan this formula. I rasa this formula is more simple. X bar KI minus X bar LI. Okay, remember the first subscript K dan L ni adalah refer kepada population ataupun treatment. Okay, let's say we want to compare the variables, the difference between the first population and the second population. So kat sini the first population and the second population for first variable contohnya. So kat sini will be 11 minus 21. Okay, the first subscript K and L tu adalah refer kepada population. I tu adalah refer kepada which variable that you need to know. Okay, alright. So, and then plus minus. This is and then this is the dia punya distribution that you need to use. Gunakan T distribution. Okay, a degree of freedom is N minus G. N adalah total sample size. Kalau ada 3 population, you need to add up all the 3 population untuk dapatkan all the 3 sample size of the population untuk dapatkan small n, N1 plus N2 plus N3. And G adalah treatment ataupun number of population involved. K alpha adalah significance level. Dan P adalah number of variable. Okay, multiply dengan dia punya standard deviation. Standard deviation here adalah WII. II maksudnya refer kepada variable. Okay, how to get the WII? WII, dia kata kat sini, here WII is the ith diagonal element of matrix W. Remember from the previous lesson, you know how to find the W when you are try to finding the weak lambda test statistic, right? So from the matrix of W, okay, you observe the diagonal. The diagonal is WII refer kepada the ith diagonal element of the W matrix. Okay, so kalau you ada 3 variables, your W matrix will be 3 by 3. So you akan ada 3 main diagonal. Yang pertama tu will be the W11. Yang kedua kat tengah-tengah tu akan jadi W22. Dan last sekali kat bawah dekat main diagonal akan jadi W33. So let's say here, kita nak compare tadi between the first population and second population. For first variable, so kat sini will be W11. Okay, boleh? Divide dengan N minus G, total of sample size, minus dengan G, which is the treatment involved ataupun how many population involved. Okay, multiply dengan 1 minus NK, sample size for first population, kalau contoh I tadi, plus 1 over NL adalah sample size for second population. Kalau I gunakan tadi first population dengan second population. Okay, so this is the confidence Bonferroni confidence interval to check for the treatment effect. Okay, from the example 6.10, okay, the average cost for nursing homes differ depending on the type of ownership. Okay, which is we reject hash note from the example 6.10. Bila reject hash note, we can say that at least one of the population is differ. Okay, so kat sini kita punya population adalah, we have 3 population here, which is the type of ownership, whether it is private, non-profit dan government. And then the variable involved, we have 4 variable involved, X1, X2, X3, X4. X1 adalah cost of nursing labour, X2 adalah cost of dietary labour, X3 adalah plant operation labour, and X4 adalah housekeeping labour. So for example 11 ni, dia kata a comparison of variable X3, which is the cost of plant operation and maintenance labour between private owned nursing homes and government. Private and government means that, kalau you refer dekat page 306, means that we want to see the difference between the first population and the third population for third variable. Okay, So nak apply the formula of confidence interval tadi, Bonferroni confidence interval punya formula, we need the value of x13 minus x13 x bar 13 minus x bar 33. Kenapa macam ni? Sebab kita nak compare between two population. First subscript population pertama, which is the private, and the government, for third variable, which is the variable of plant operation and maintenance. Okay, so you need to find this difference of mean first. Okay, so you just boleh ambil daripada mean vector for first population and second mean vector, the third ataupun mean vector for the third population, which is the government. So kenapa yang ambil kat sini? Sini because of 0.082 and 0.125 adalah mean for third variable cost of plant and operation tadi. Okay, dalam your textbook dekat example 6.11 tu dia gunakan tau, kan? Dia gunakan tau, so I edit sikit kat sini. Okay, so maybe boleh edit juga. Boleh juga you can use the formula of tau, cuma you need to find the difference dululah between the tau 1 and tau 3. You kena cari dulu what is tau 1, what is tau 3. But same if you use this method. Terus je boleh ambil using the difference of mean. Okay, so we apply the formula. These two tadi, 0.082 minus 0.125. We can find this from the mean factor tadi. Okay, plus minus T. Okay, 516 adalah total sample from the 3 population, minus dengan 3, which is we have 3 population tadi, private, non-profit and government ataupun 3 treatment. Okay, alpha we use 0.05. Okay, variable is 4. We have 4 variable. Okay, 1.484 adalah W33 because of, okay, we find the confidence interval between private and government for third variable. So kat mana nak ambil 1.484 is here. Okay, is here 1.484, which is the the third element from the main diagonal matrix W. Okay, the 271 is the sample size from the first population. 107 is the sample size from the third population. Okay, when you have all this value, just apply the formula. Last kali you akan dapat negative 0.061 and negative 0.05. Okay, so from here, because of there is no zero includes in the interval, we can say that there is a significant difference between private and government. Okay, there is a significant difference between first variable and the third variable for there is a significant difference between first population and third population, okay, for third variable. Okay, so bila kita tahu ianya significant, barulah you can then you can interpret the confidence interval. We can say that the average mean of labor cost adalah X3 tadi. The average maintenance and labor cost for government adalah population ketiga. Okay, government owned nursing is higher by 0.025 and 0.061 hour, dia punya unit per patient day, than private nursing homes. Kenapa buat jadi government higher? Because of government tu adalah third population. Sebab dapat negatif kan, so government lagi higher lah. Ataupun you boleh juga twist, you boleh katakan the average maintenance for labour cost for private nursing home is higher. Is lower than by 0.025 to 0.061 hour per patient than government nursing homes. Okay, so this confidence interval you boleh cari untuk population pertama dan population yang ketiga for third variable. Untuk third variable sahaja you boleh interpret. And then also you can interpret gunakan using the same method, cuma ubah dia punya value apa yang akan berubah. Value di sini dan juga di sini will be differ. Untuk you nak tengok confidence interval between private and non-profit, which is the first population and second population. Okay, so here is the final answer. You akan dapat negative and negative juga. Means that there is no zero in the interval. So there is we can say that there is a significant difference between the private and non-profit owner of the housing. The nursing house. Okay, bila significant, then we can interpret the confidence interval. The average maintenance and labour cost still X3 kan, for non-profit, which is the population yang kedua, is higher sebab negatif kan. So population yang kedua lagi tinggi daripada population yang pertama by 0.026 to 0.058 hour per patient than private. Okay, let's see pula the third one. Bila kita nak tengok confidence interval ataupun the significant difference between the second population and the third population. Okay, so from the confidence interval that we get, the value will be negative dan positive. Means that the zero will be in this interval. What we can say that, so daripada situ terus kita boleh katakan there is no significant difference between non-profit and government nursing home in the average maintenance labour cost. So kita tak boleh nak interpret the confidence interval because of there is no significant difference between these two population untuk X3 sahaja. You also can use the same method to find the significant difference between the population for the other variables X1, X2 dan juga X4. Cuma dia akan berubahlah di sini. Kan dia punya value di sini. Okay. Itu sahaja untuk this topic. So kita sambung another one. Okay, the next topic is testing for the equality of the covariance matrices. Okay, as you know, one of the assumptions made when we compare two or more multivariate mean vectors is that the covariance matrices are equal. Betul tak? Okay, so before we find the pool covariance matrices, okay, when comparing mean vector, it can be worthwhile to test the equality of the population covariance matrices. Okay, so we can use box M test to test the equality of G population covariance matrices. Okay, so I go straight to the procedure how to use the box M test. Okay, hash naught will be the big sigma 1 equal to big sigma 2 equal to big sigma G equal to big sigma, which is we saying that the covariance matrices are equal for all the population. Ataupun in words, we can write it as the covariance matrices are equal. Alternative hypothesis pula, at least two of the covariance matrices are not equal, ataupun we can write it as the covariance matrices are not equal. Okay, the test statistic is actually C here, the test statistic for box M test. But in order to find the C, we need the value of U and value of M. Okay, so U, the formula of U is 1 over, summation of 1 over and L minus 1. Okay, so that part you need to calculate the value of 1 over n minus 1 for each of the treatment ataupun population. Okay, minus 1 over summation of NL minus 1. So you need to find the NL minus 1 for each of the treatment, then you sum up. Okay, baru you find the difference between those two parts. Okay, multiply 2p square plus 3p minus 1. P is number of variable involved. Divide 6 multiply p plus 1 multiply g minus 1. G adalah how many treatment that we have. Okay, M pula, to find M, it is summation of n L minus 1. Okay, same as above. You need to calculate n L minus 1 for each of the treatment, then sum up. Multiply with ln as pool. So here you need to find the as pool. The formula is same like before this in the previous topic. Okay, ln of the determinant of as pool ataupun okay, the determinant of as pool minus summation of NL minus 1 multiply ln determinant of SL. So first of all, you need to know the variance covariance matrix for each of the population. So it is the SL. Okay, find the determinant, then lnkan the value, and then multiply dengan n minus 1 for the corresponding population. Baru you need to do that for each of the population, sample population, and then you sum up tu untuk dapatkan M. Okay, then since we have the value of U and M, so just apply the formula C, which is 1 minus U multiply M. That is the test statistic for box M test. Okay, so what is the decision rule? Decision rule will be, we reject hash knot if C more than the chi-square with the degree of freedom P multiply P plus 1 multiply G minus 1 divided by 2. Okay, here in this slide tertinggal missing the part of the decision rule. So you can see in your textbook page 311. Okay, ada dekat situ. We reject hash knot if the test statistic C more than the value from critical value from the chi-square distribution with the degree of freedom P multiply P plus 1 multiply G minus 1, all of that divide by 2. So if our decision is reject hash knot, we can conclude that the covariant matrices are not equal. If we reject hash knot, the covariance matrices are not equal. Okay, let's see the example. Example in your textbook, look at example 6.12. Okay, so this example we refer from the previous example 6.10, which is from that example 6.10 we have all the information about the P, G, of course, the sample size for every population, and the covariance matrix variance covariance for each of the population. And then also we have the value of S pool, Okay, so we need all of this to calculate the U and M. Okay, so from the previous example, we know that it is about the nursing ownership of the nursing homes, right? We have 4 cost variable, and we have 3 groups of nursing homes, which is private, government, and non-profit. Okay, so we will use that example to conduct this box M test. Okay, so hash note will be big sigma 1 equal to big sigma 2 equal to big sigma 3, because we have the 3 treatment groups equal to big sigma. Okay, hash 1, at least 2 of the covariance matrices are not equal, or you just can write it as hash note. The covariance matrices are equal. Hash 1, the covariance matrices are not equal. Okay, we use the value of alpha 0.05. Okay, so to find the test statistic C, you need to find the U first. So let's see here. The first part here, 1 over 270, because of our N1 adalah 271. So it will be 1 over 270 plus 1 over 137 plus 1 over 160. So this 3 part you need to sum up. Okay, minus dengan 1 over summation of NL minus 1. So every sample size tadi, we need to deduct 1 from that sample size, then sum up. Okay, so these 2 part sum up, this part, then minus dengan this part, you akan dapat that one. Okay, and then multiply dengan 2 multiply 4 square, because of our P ataupun the number of variable cost tadi adalah 4. And then here G is 3, because of we have 3 treatment groups ataupun 3 population involved. Okay, so apply the formula. Last kali you akan dapat 0.0133 for U. And then to calculate M, it is summation of N minus 1, which is this part here, that you calculate the sum up of the NL minus 1. Okay, multiply dengan ln of S pool. S pool, determinant of S pool, we have the information from the previous example. But if not, you need to calculate the value of S pool using the formula given. Okay. Alright, so here you get the ln of S pool minus dengan summation of NL minus 1. So every part of the treatment, you need to calculate the NL minus 1 to 70, multiply dengan ln of SI. Okay, we have the SL. So we have the every variance covariance metric for each of the population. So find the ln of that, the ln of the determinant of SL. Okay, so after you multiply, baru you sum up. Okay, sebab dia ada summation kat depan ni. Okay, and then apply the formula, then you get 289.3. Replace in C formula, then you will get 285.5 untuk dapatkan nilai C. Okay, so we can compare the C with chi-square, the critical value from the chi-square distribution. Okay, with degree of freedom of P 4, P plus 1 5, G minus 1 is 2 because of 3 minus 1, divide by 2. So it is 31.41. Let's check your chi-square table. And then because of C, which is 285.5, more than 31.41, so we can conclude that hash note is rejected. So what can we conclude from this decision rule? We can say that the covariance matrices of the cost variable Sebab variable kita tadi cost kan, ada 4 cost. The covariance matrices of the cost variables associated with the 3 population of nursing homes are not the same. Ataupun you can just saying that the covariance matrices are not equal for the 3 population. Okay. Sorry, battery dah low. Okay, that's all. Okay, satu lagi. Okay, so biasanya untuk box M test ni, kalau you nak cari C kan, it's very complicated. Banyak benda yang you need to find kan. So it will takes time for you to calculate the value of C. So usually in exam biasanya the value will be given. Maybe the value of C ataupun dia terus bagi you the value the output from SPSS. So you can also make the decision from the P value. Okay, as you know, we reject H0 when P value is less than the value of alpha. So from that you can make the conclusion about the equality of the covariance matrices. Okay, but still you need to know how to calculate the value of C here secara manual. Okay.